Good afternoon, and welcome to this conversation on CRAN and fronthaul. This is part of a report that Senza Fili has prepared in collaboration with RCR Wireless. And today we're talking to Ken Sandfel, the Executive Vice President at Solid Technologies. Ken, thanks for being us today.
Good morning, Monica. Thank you for having me.
So let's get started and talk a bit about what is Solid doing in the CRAN and fronthaul space.
So Solid is focused on the optical infrastructure for CRAN. So the development and manufacture of unique optical network solutions that solve the different problems that are faced by operators looking to build a CRAN network topology. So we're focused on the physical layer solutions for those new style of networks.
Right, and so what is that you see in terms of the CRAN and fronthaul deployment? Because the end game is CRAN. Fronthaul is what you really need to get there.
Mm-hmm.
Can you tell us a little bit about what's the relationship there?
Yeah, so the relationship is, with CRAN, the goal is to have the bulk of your processing being done in a central location, and thereby, overall increasing the performance and the coordination of your assets, right, at the central office. And so what the optical solutions are there to do is to package provide the scale for the network to be able to grow differently than previously was required. So with a CRAN architecture, you're trying to push the assets back into the core, which means you have to change the way you deploy the topology on the access side of the network. So what that's required is it's required a different combination of network solutions with use of CWDM, DWDM. We have the capability of combining things like GPON, Ethernet, CPRI, all in the same fibers, thereby increasing the flexibility of the architecture. And that's really what we've had to focus on is the unique packaging of those solutions so that it better fits the network operator's requirements, because the traditional solutions just were not packaged and were not set up for that type of density. They were set up for more of for more point-to-point links, and so this has enabled the operators to be able to design these networks and deploy them in this fashion. So it really has to do with the number and type of services that you're trying to run across the cabling.
Mm-hmm. So why is it important to be able to mix and match different protocols?
It's very important because no longer do you lease a dark fiber from point A to point B and say, well, that's all I need to do. The reality is there's going to be stops along the way. You might need to drop Ethernet for Wi-Fi. You might drop Ethernet for a small cell on a pole, and that fiber asset may continue down that street. It may also go into a building where you might need to provide some broadband. No, in the case of wireless operator, that's not typically the case. In Asia, the same operator that supplies broadband at the building is supplying wireless, so it makes sense to have the ability to drop two different types of services. However, in the end, the ability to mix and match those services on wavelengths is what's proving to be very powerful in the TCO solution.
Yeah, I was about to say this is a way to really leverage your resources in a more efficient way, and that's quite important when it comes to CRAN, because oftentimes what you hear is that one of the major obstacles to CRAN is that yes, you're going to have cost savings, but you have all the fronthaul that basically drags everything down, and because it's so expensive. So how can you help with that part?
The upfront costs of the network, the building new topology is going to be more expensive than the way we deploy today. And the reason it's going to be more expensive is because you don't have a ring. You're not trying to build a ring and then just add long access trunks off of that. You're essentially building multiple rings, and then you're building a whole new access network is what you're building. And that's expensive because you have to put up new fiber in the ground, and you're going to go into locations that you've never been before, and that's more expensive. The benefit of doing so is that you have closer access to the nodes that you're going to use for future densification, and you also have the physical layer infrastructure, which we manufacture, that allows you to continue to add services without any additional fiber requirements. So by adding additional nodes out there, whether it be a small cell node or whatever type of densification plans that you have, the only additional equipment that's required is really just a card or activating additional ports into the ring. And so the wavelength services is what enables all that, right? It enables you to scale virtually on your fiber, and that's really what's most important. The other, not only scaling in quantity of ports, but in the type of service. Like I said, Ethernet and CPRI are going to be interchangeable. You might even have to run both to a given node. You might have Wi-Fi at that same node as well. You may be supplying a radio head that's supplying service in the city for the Super Bowl, and at the same time, on that same pole, you're going to have to do Wi-Fi, and so you're going to need multiple services, and you may not have enough trying to just supply one box with that service. You need to add additional.
So this sounds like a good TCO in the long term, although on day one you require more investment to set it up, because you need, and that's the whole issue, I guess, with vRAN as well, that the gains are more in the long term, even though in the short term you might need to have some investment. So is that, you see that to be a challenge or something that is slowing down the deployment, or are operators ready to move on with this?
I've been watching it now for 3 years, and it's a very strategic investment. It's a big investment, and it requires a lot of change in the way things are done from a procedural standpoint. And I think those changes they're still being made, right? Today, the way I see deployments happening for a radio head or other small cells, that's one of the biggest problems, is the procedures that's being used are the legacy procedures, legacy documentation, legacy steps for activating that particular the device. And that's what's really slowing things down, in my opinion, from what I've been seeing over the years now. And it's going to take some time for that to change. But I believe that investment, it is a big investment up front, but it is very strategic, and it just requires that a mind shift take place. It's just like the switch from, going from 35-foot macro poles to 20-foot, inner city poles, right? Or even just, by densification, you're effectively trying to cover less area. And so those are changes that just take time for everyone to learn how to adopt. Plus, we have a very robust macro network that we have to re-optimize, and that's one of the steps in densification with Cloud RAN, is that you have to reapportion the macro network to be able to accommodate all this densification. And actually, some of the macro locations will potentially even go away because they're not suitable for that environment anymore. You're going to go from a big tall pole, and you're going to need lower locations. Now, that doesn't mean that physical location goes away. You may have a 20-foot shelter on it. You might actually repurpose it, and you might actually make that an aggregation point for all your fiber.
Yeah. So there is a lot of differences between the legacy. I mean, there is obviously a lot of legacy networks out there that you need to deal with, and then there are greenfields where the choice is much easier because you don't need so much strategic. This decision it's sort of already there. It's easier to make because you don't have legacy. So I wonder whether you can comment on the difference where you have among different regions. I know you do a lot of work in Asia as well. What do you see the difference in terms of the ability to have the strategic vision to move forward?
Well, a lot of people, almost everyone that in the U.S., the North American environment will tell you, it's different over there. And some of the big reasons it's different, it really has to do with the rules on fiber, and the access to new fiber, as well as the rules associated with that carrier providing multiple types of services on those. We have much different rules here. So that causes things to be a little slower. However, from an LTE deployment perspective, the problems are the same. So that means the solutions are going to have to be similar. So regardless of how they deploy and how hard or easy it is compared to the North American market, the physical challenges are the same. You have to, the topology is the same. It has to go together physically the same way. And so, that's a big perception that I've been watching. It's certainly they have it easier in a lot of ways, and we could be a little envious, right, that they're able to move so fast. But it doesn't prevent us from doing the same thing. It just means that we have to strategically decide that we're going to have to make a different investment in changing the topology of our core networks and the access networks when we serve the cities. And from the wireless network perspective, operator perspective, that's going to be a big strategic step. And the investment required is going to be substantial. And it may even change, the entire model completely. Going from it's kind of like when the carrier started, selling assets to the tower companies, and they're saying, what, we don't really need all those. Well, there's a potential we could go through a similar revolution of a different type with regard to densification, because now you're putting up, a 15-foot pole on a light pole on a street, and who wants to own that? Does the city own it? Does a third party own it? Does the carrier own it? And those are things that we're going through right now. And but it does come back to the fiber usage, and fiber is going to be a very important commodity, as we go here. So usage of the fiber is what we're focused on.
Yeah. But in North America specifically, isn't there a little bit? There is some difference in terms of the density of everything. So we are more spread out than in Asia and even in Western Europe, and also the ownership issues. So is that going to make the North American market, it's a little bit different than Asian markets?
Well, the investment is certainly bigger, because when you're densifying to that level, you have more square miles of coverage to densify. The U.S. has always been, your big, your NFL cities, right? That you're going to try to serve first. Where is your population? But the reality is the physics are the physics, right? You have to. This isn't the coverage days. This is capacity days, and there's no way to deliver that capacity without having a pole near that user. A lot of my folks from Asia travel to the U.S., and they're always amazed that LTE service is a matter of a couple bars, whereas in Asia there's 5 bars everywhere. And the reason there's 5 bars isn't because they have more RF coverage blasting through the window. It's because they have more devices close by to serve the customers, and that's why they have such strong RF coverage. And so, unfortunately, there's no easy way around it, Monica. The reality is, we're going to start at the city cores, and we're going to have to build out from there. So we first have to make the strategic investment in the cities, city by city, and changing the topology of our network. And that's one of the reasons you see so many people trying to do wireless connections to these nodes, right? Because they're like, well, geez, I've got to do a gazillion of these things. I can't afford to run fiber to all these. And I think that's those solutions are going to be very critical in the build out of these networks. However, all of these services ultimately have to aggregate to these points in the network, and the aggregation points could either be the existing macro nodes buildings, or they could be the other CO offices in the city. But the reality is, it's still going to be a big shift in the topology of the architecture. I mean, there's just no way around it. Mm-hmm. If we don't, we're going to be here many years from now talking about this. There's just no way around it. It is. You hear people say it's a physics exercise, and it really is. It's just like Wi-Fi in that perspective, right? If you're not close enough, you don't get enough bandwidth, right? So it's the same thing.
Yeah, but when you talk about macro cells, it's one thing. But when you start talking about small cells, it becomes a little bit more challenging, because, as I say, there is already the issue of ownership, but it's also the issue of where you put the small cells. You need to be very close to the users. The closer you get to the users, the more complex it gets to get fiber there, so to say, right?
Mm-hmm.
Generally speaking. So, what can operators do? in terms of, because to get fiber on a lamppost is more difficult than get it onto a cell tower.
Well, I think that's where in-building coverage is going to come in to augment. We're not going to try like we do today. You have in a city, you have down tilted antennas and all kinds of crazy things to try to provide some coverage inside inside buildings, and that's where the in-building solutions are going to come back. And I believe the enterprise, the building owners are going to take some participation in that. Some buildings are going to utilize their bandwidth that they're to supply their service to their facility, just like they supply Wi-Fi today. I believe there's going to be network solutions that allow them to provide future license band coverage, and that's something that we're all working towards in this industry. In addition to the fiber networks, Solid is very focused on those solutions as well. But so I guess what I'm saying is the pipe to that building may be paid for by that enterprise to supply licensed and unlicensed services. And there could be co-participation deals, right? Once you get to the point where you're all that IP is all controlled by a gateway to the facility, to that building, now you can decide who pays for what, right? It's who pays for what packets and all that kind of stuff. And then when you get back to the city street, that's going to require more, more ownership and more planning for the carrier to provide that, because that's clearly an outdoor space and it's public space. But once again, though, there's going to have to be fiber down those streets to make that work, and there's no other way around it. Whether it's leased or owned or trenched or it's wireless, that connectivity has to come into play. And I believe they're gonna do it one block at a time. They're gonna do it one building at a time. 70% of the North Americans' buildings are not covered. The average facility that you and I travel to in North America has no coverage. And if it does, even it's an old system and it needs upgrading. It's designed for 3G, and so you may have a little service because they added an eNode B to it, but there's not enough bandwidth or enough density on the RF to make it even work properly. And that's a problem for the carriers. I've been deploying DAS now for 12 years, and thousands and thousands of sites, and I would say like half of them are old now. So and we're kind of shifting away from the cloud RAN, but the reality is, that's what's going to be driving it, right? So, and with Cloud RAN, I mean, let's we got two separate buckets too, right? You have your CPRI based, BB, base unit and remotes, and then you also have, the Ethernet fed small cells, right? So regardless, you're talking about a virtualized core, right? And that's really designed so that we can deploy the nodes and the densification faster. I mean, it's all about speed. I mean, lowering the costs, increasing the speeds to deployment. And so the fiber network equipment is getting cheaper. I haven't seen any studies recently on the cost of fiber, but obviously, if you can, which is why we're focused on virtual fiber, right? If you have to buy the fiber, dark fiber, it'd be nice if you can do not just one thing. Maybe you can do 48 things with that fiber, and that's what we're all about, right? Is really trying to make more use of that infrastructure in a more efficient way to lower your TCO, given that eventually you're going to have to invest in that infrastructure. So let's make it more efficient.
Mm-hmm. So what is your specific proposition specifically with CRAN to operators that are trying to slowly going through the transition, because it's not going to be an overnight, as you said, it's not going to be overnight. So they need to have help moving forward. How can you help them specifically?
Well, in the beginning, what's going to happen is they're going to start. Well, they're already doing it. The carriers are going to deploy. They're going to deploy, basebands and radio heads for outdoor solutions as a migration for the current macro topology. Right? You'll even see the television advertisements. We're putting the smart stuff on top of the pole, right? And so that's kind of the first evolution, and that's been going on for a long time. It's only recently that the whole Cloud RAN, all this stuff has kind of been named and everything. But so that's already been done, and it's being done on a more traditional level, right? So all right, now we need more fiber going from point A to B, and that's it. It's all the fiber going from A to B, and then there's this pole, and then you have these really smart radios on top of the pole. that's not densification. That's just designing a more efficient macro pole, right? So how do you duplicate that times 1,000 in that area? The reality is, you can't. You have to change the way you deploy. And so right now they're going to continue to trial the electronics to make sure all the electronics work. They're going to be testing all the software. I think the software is probably one of the biggest reasons why they've been, it's been slow, right? They're trying to test all the software so that they can deploy these things quickly and have all the interference be managed automatically, right? So they don't have to do so much planning every time they make a little change. And that's going on right now, and has been for years. So once you get to the next step, how we're going to be able to help them is they're going to say, well, geez, we don't need to deploy 10 sites here. We need to deploy 100 or 1,000. And we know we have fiber in these areas. The fiber companies are going to become a real big part of that. So they're going to take the carrier-owned fiber assets. They're going to take assets that they can lease or acquire some other ways, and they're going to design new topologies from that perspective. So what we're going to do is we're going to be able to provide them with the physical electronics, the optics, to be able to utilize all that infrastructure. But it's not until they make that decision that they need to build their network that way that we really come into play. One of the reasons we haven't really kicked off in a huge way in the North American market is we haven't gotten to that problem point yet. Right now, when you ask a carrier, well, I have enough fiber going to that pole. I have 12 strands going to that pole. What else do I need? Well, it's not until they need to build 10 poles around that pole that they go, oh my gosh, I don't have enough. I don't have any fiber. But they know they have the 12 strands going to that pole. So once they know they have that, that's what the Asian markets did. They said, well, we know we have 12 strands, let's just say as an example, going to this pole, and there's a shelter next to it. So we know we have a connectivity to that point. So now how do we get to the other 100 poles that we're going to put up around that? And so that was their way of looking at it. Let's use what we have from a network. We've been investing in it for years. Let's try to see what we have and then kind of scale around that. And that's really where the Cloud RAN, optical network solutions really come into play, because you have 12 strands. So now how do you make better use of those 12 strands? So the reality is right now those 12 strands are 100% full. Once we go to the Cloud RAN topology with the optics, we're probably only going to end up using 2 or 3, because we're going to take those 2 or 3 and we're going to create 48 virtual paths or more on every one of those fibers. So now all of a sudden those 12 strands, we've got lots of excess capacity, and that's where the TCO model is just awesome, because now when the next year comes 5G and the next year comes this whatever, now we have plenty of growth and scalability in our infrastructure to be able to add more channels into this architecture and grow however we need, up to a certain extent, right? Up to the physical assets that you have acquired.
Yeah. Well, and I think that you raise a very important issue here, that you need to get to a situation of semi-crisis, when you say, oh, I have to do something. And that's the same thing with small cells. It's bad, but it's not bad enough to really get operators to move full tilt. So you might have this small, relatively contained deployments, which are not quite what is going to happen. We know it's going to happen. The question is, it's when more than, how long it takes before they really have to do it. So let me ask you in closing, what should we expect from Solid over the next few years? What are your direction of development in terms of products, trials?
So as we've been working through all the Cloud RAN possibilities in the Asian markets and actually learning, with the carriers and what's working, what's not. We're modifying our products. We have a lot of new patents and new technologies that we're looking to bring to market. And we believe the timing of these new technologies will happen right at the point where the North American operators are going to say, wow, and actually the European markets as well, which is a big focus for us. They're going to have a need for these type of solutions. And these are, these aren't just run-of-the-mill optic solutions. These are new patented ideas and architectures that are totally different than the way things are deployed today. A lot of people commonly lump optics, well, it's a piece of optic cable and you put stuff on both sides. Yeah, but how you package that and how you put that all together and how much you can do across the fiber is something of an art form. and science. So you're going to see a lot of new exciting solutions coming out of our factory, and that's obviously going to be combined with the coverage enhancement solutions on DAS, as well as other radio solutions that come from Solid. So we're actively looking at all aspects of the densification of the network. As part of this conversation, we're focused on new technology as specifically geared towards making the CRAN network deployments much more cost effective and much more powerful for the network operator. And I think we're right at the cusp of that starting. I think we're right at that point. We spent all these years recently, overlaying LTE, and now we're getting to the point where densification is really adding lots of new nodes. So that's really where we see things at pretty soon here.
Well, thank you. That's very exciting. And I think you hit an important point that you need to look at densifications as a whole issue rather than one specific solution, because that's where you're going, and you might need to have different ways to deal with it depending on where you are and what you're trying to do. Yes. So, well, Ken, thank you very much for sharing your views with us today.
Thank you, Monica. I really appreciate it. Thank you for having me today.
Well, thank you for listening in, and this was a conversation with Ken Sandfel at Solid, and it's part of our report at Senza Fili on CRAN and fronthaul that is prepared in collaboration with RCR Wireless, and it's available on our website. Thank you very much.